The essential question in this video is, if I know two things are similar, how can I find missing measurements? If I know two things are similar, how can I find missing measurements? Let's take a look at the first column here first. And I have a little note that you need to copy down. There's a couple example triangles here. Let's go ahead and label the vertices because we're going to talk about these vertices in a moment. So I'm going to label this one as A, and this one can be B, and this one C, and let's do, doesn't really matter, D, E, and F. And the text below these two triangles is, if you want to write that the two triangles are similar, you must put the vertex letters in order so that corresponding angles are in the same position. So if you take a look at these two triangles, you need to figure out, how do I label both of these triangles so the first letter I use for each triangle corresponds to the same angle, the same corresponding angle on the other side or the other triangle. So let's take a look at this. I'm going to try to do this. I'm going to have to scroll a little bit so you're not going to be able to see these triangles all the way, but let's take a look at these two triangles. You can see that that angle A, which is 30 degrees, matches up with angle F, so put a circle there. And then I can see that angle E, which is 40 degrees, I'm going to put a double circle on that one. That matches angle C. And then the two angles that I'm not marking, I can tell you, and we'll actually cover this if we haven't done this already. We'll cover it in a different video. These two angles also must be congruent, because if the angles of a triangle add up to 180, then we can figure out that these two angles will also be congruent. These two angles I'm not going to put a mark on. I know they go together because they don't have circles around them. So here's what I want to see about these two triangles that I'm going to write on the bottom. Okay, take a look at this. Since angle A is congruent to angle F, and we know that because both of those have the same angle measures, we put a circle around them, and angle C is congruent to angle E. Again, those are the two we put double circles around. Then the way you would write that they're similar, and let's say we know they're similar, the way we're going to write this is, we'll put then you would write, and here's our similarity statement. You would write that triangle ACB is similar to triangle FED. And take a look at this. The positions matter. Since A and F go together, they can be in the first position or the same position. C and E are congruent, so I put those in the second position. And then the final angle that I didn't mark, those I know are congruent as well. Those go in the third position. I could have rearranged these. I could have said BAC or ABC, as long as when I rearrange them, I rearrange these three letters so that they still match up with corresponding angles. A always has to be in the same position as F, C and E, and B and D when I'm looking at these two triangles. So that's the first thing I want to cover with you is, if you want to know what this is called, it's called the similarity statement. Let's just label that. This is the similarity statement. And this similarity statement is going to be used throughout this unit to show you how you can find all sorts of things about the two similar shapes. In most of the cases triangles, but sometimes it could be quadrilaterals or other shapes. Alright, so let's take a look at our example here. If triangle ABC is similar to triangle DEF, they're talking about these two triangles. If we know they are similar, then let's go through a couple questions here. The first question is, what is the proportionality statement? And proportionality statement basically matches up corresponding sides in ratios. So it's easy to do. We don't even have to look at the shapes to do this. We're going to look at the similarity statement. I know that side AB is corresponding to side DE on the second triangle. Now look at the next two letters, BC. I know that BC corresponds to side EF. Notice I'm just matching up the letters because these letters have to be in the correct order. They match up with congruent angles. That means they tell us corresponding sides. And then my final ratio, because a triangle has three sides, we're also going to have the first and the third letter. Sometimes I'll write the third letter first and then the first letter. It doesn't make any difference. CA is corresponding to FD. Now I want you to see something that I did here, class. As you're going through these letters and matching up the sides, if you start off with the side from the first triangle on top, you have to keep all of the sides of the first triangle on top of every ratio. If I started off with DE on top, then every top part of the ratios, or every numerator, would have to come from triangle DEF. You can't say AB over DE is equal to EF over BC, because now you pick the numerator from the first triangle here, and then you pick the numerator from the second triangle here, and that is not allowed. Make sure that whatever shape you start with on top, that shape, those shape letters continue to be on top for every one of the ratios. So here's our statement of proportionality. It tells us which sides correspond to which sides, and it comes right from this similarity statement. Okay? The next thing we can find out is, let's find some things that we know about the diagrams and label them on our proportionality statement. So let's take a look. We are given the length of side EFCA. We know the length of side EA. So what I'm going to do is, the length of side CA. So I'm going to circle that just so I remember I know that measurement already. And then I also know what FD is. I'm going to circle that one. And then I'm going to circle DE because I know that side length. Those are the three side lengths we've been given. This is important, class, because you can find the scale factor now from the ratio that you know both the numerator and the denominator from. So let's say I want to find the scale factor. Well, scale factor is based on which of the shapes is the pre-image. So if I look at this, I got to say, well, they don't tell me which one's the pre-image. So I'm going to go ahead and just say, what if? What if triangle ABC is the pre-image, if triangle ABC is the pre-image, then remember my scale factor is always a measurement from the image over the measurement from the pre-image. Let's take a look. Which of these would be from the pre-image? If ABC is the pre-image, then AC is the side from the pre-image. Here's our pre-image triangle. So pre-image goes on bottom. That means side CA has to go on bottom. And then the same measurement from my image goes on top. Well, the side that corresponds to CA is FD. FD is 6. So that means my scale factor here would be 6 over 3. And I'm going to reduce that now to, let's see, 6 over 3 is divide both sides by 3, and you get 2 over 1. Let's see if that makes sense. If triangle ABC is the pre-image, then I can see that to get to FDE, the other, or DEF, the other triangle, I'm enlarging my original pre-image. That makes sense. This scale factor is greater than 1, so that must be an enlargement. So I'll put on here my scale factor. In this case is 2 to 1. And that is enlargement. Now, I'm going to draw a line here, and let's just go ahead and do the other one. What if my other triangle is the pre-image? What if triangle DEF is the pre-image? Okay, in this case, when I do image over pre-image, now let's take a look. My triangle that's my pre-image is DEF, my starting point. And now I'm going to put FD on the bottom. So now the pre-image measurement is 6. And my image measurement is 3. So this means my scale factor is 1 over 2. Let's take a look. If DEF is the pre-image, then we're clearly reducing to get to triangle ABC, so a scale factor less than 1 makes sense. So in this case, my scale factor is 1 to 2, and that is a reduction. I'm going to fix something over here where it said scale factor. I'm going to make that an equal sign to match with my right side. So when you're looking for scale factor and you're not told what the pre-image and the image is, you're going to have two possibilities depending on which shape you choose as your pre-image and which shape you choose as your copy or your image. So there's some information about finding scale factor. Alright, let's go to the important part, which is finding missing parts. Now remember, one of the things we did in the previous part of our video is we also not only looked at this, we're not only looking at the corresponding sides, we're also looking at corresponding angles. Let's do that right now. Angle A, I'm going to circle that. That corresponds to angle D. They're in the first position. I'm going to circle that. And angle B on my first triangle, I'll double circle that, corresponds to angle E. I will double circle that. And then C and F also correspond to each other. So once we have corresponding angles, we can actually start finding missing information about angles. What is the measure of angle B? We'll take a look at B. B has a double circle. That matches up with angle E. If E is 40 degrees, then B has to be 40 degrees, and I'm going to label that. So measure of angle B is equal to 40 degrees. And it's because angle B is congruent to angle E. So the measure of angle B is equal to 40 degrees. Alright, let's take a look at the measure of angle C. Okay, we got a problem now with angle C, because angle C, notice, its corresponding angle is F, and neither of these have an angle measure. But we can be saved by the knowledge that the angles of a triangle add up to 180 degrees. So if I want to find the measure of angle C, I can take 180, I can subtract this angle A right here, which is 90 degrees, and I can subtract angle B, which I know is 40 degrees, and you put that in your calculator and you're going to end up with 50 degrees. So based on the knowledge that the angles of a triangle add up to 180, we can find that, we can say, so the measure of angle C is equal to 50 degrees. And I'm going to go ahead and label that on my diagram. It's kind of small, but we'll write a 50 degrees. And the last question is, what's the measure of angle F? Well, this gets easier. C and F correspond to each other. So if C is 50, then F is equal to 50. So since I know that angle F is congruent to angle C, then I can say, so the measure of angle F is equal to 50 degrees. So now we've got all of our angle measures. I'm going to write 50 up here. I like to label as I go because I never know if I have to use that information for later. Alright, last thing is, let's find the missing sides. Alright, so here's how this works, class. If you're going to look for the measure of angle B, if you're going to look for the length of side AB, here's what we do. We're going to go look at our proportionality statement. Since we know the lengths of CA and FD already, we're going to put those in our answer. We know CA over FD, and we know both of those measures. And now let's take a look at AB. AB is part of the first ratio, so I'm going to have to write that as well. That's going to be equal to AB over DE. Now, the good part is, think about this. We know CA, we know FD, we know DE. We can solve for one of the missing sides, which is AB. Let's go ahead and fill in the values that we know. CA is equal to 3. And then FD is equal to 6. And that's going to be equal to AB. AB is the one we don't know, so that is going to be x. And then the last one, DE. DE is equal to 8. Now if you take a look at this, this is just a proportion where we have to solve by using cross multiplication. 6 times x is 6x. 3 times 8 goes on this side. That means 6x equals 24. Divide both sides by 6, and you've got x is equal to 4. And if x is equal to 4, that means that AB is equal to 4. So our final answer is AB, I'll put the word so AB is equal to 4, and our unit of measure is inches, so 4 inches. So I've just found the length of AB, and I'm going to do two things, class, because I have to ask for more questions. I'm going to label as I go. This is 4 inches. And also what I'm going to do is I'm going to put a dash line or a dash circle around AB. I didn't know it originally, but I know it now, so I can use it if I need to. Alright, let's find the length of EF. Now here's our problem with EF. EF is in a ratio where I don't know the other side. So in this case, you cannot use ratios to solve because I don't know BC or EF. This is where the Pythagorean Theorem comes into play. If you take a look at EF, you see that EF comes from the big triangle, and I know the lengths of the two legs, 6 and 8. So I can actually use Pythagorean Theorem to find the hypotenuse. So I'm going to write down a squared plus b squared equals c squared. My a value I can use is 6. My b value I can use is 8, and that's going to be c squared. This is 36 plus 64 equals c squared. 100 equals c squared. If I square root both sides, I'm going to get c is equal to the square root of 100, which is exactly 10. So if c is equal to 10, that is the length of EF. So my final answer is, so EF equals 10 inches. And now I'm going to label that on my triangle, 10 inches. And I'm going to also go ahead for EF, and I'm going to put a dashed line around EF because I now know what that measure is. Last question, BC. What is the length of BC? Well, look at this. I can do the same thing I did with EF. I can solve it by Pythagorean Theorem, or I can solve it with proportions. I'm going to go ahead and use proportions just to give you more practice on that. So to use our proportions again, I'm looking for BC. The first thing I'm going to do is pick a ratio that I know both the top and bottom. So I'm going to go ahead and use CA over FD. You can see I could have used AB over DE now because I know both of those measures. And then I'm going to look for BC, so I've got to find the ratio with BC in it. BC over EF. I can use that now because now I know what EF is. Let's go ahead and plug in what we know. CA is equal to 3. FD is equal to 6. BC is our unknown. And we just figured out that EF is 10. Let's use cross multiplication now. So we've got 6x is equal to 3 times 10, and I'm just going to go ahead and multiply that out. 3 times 10 is 30. Divide both sides by 6, and x equals 5. So my final answer is, so BC is equal to 5 inches, and like everything else, I'm going to go and label that on my diagram now, 5 inches. So we just use the properties of similar triangles to not only find all the missing angles, but also to find all the missing sides. The two key things to see here are know how to write your proportionality statement, because that will help you solve for missing sides, and don't forget to label your corresponding angles with a circle and double circle. And if you're using a quadrilateral, you can pick the third angle and use a triple circle. No matter what the shape is, you just use circles to identify all the vertices that are corresponding, except for the last one. That one you can leave blank because that's unique enough. We can tell that those two blank ones would also correspond to each other. So there we go. There is how to use the rules of similarity to find missing measurements.